students. Herewith I am presenting in front of you the session number 16 for BSc Physics, 3rd semester, Rani Chennamma University, Belagavi. As you know that last session we have learnt about Huygens eyepiece, which is a negative eyepiece. This time you are going to study about Ramdan eyepiece, which is said to be a positive eyepiece. So from the previous class we learnt about Huygens eyepiece, cardinal points of Huygens eyepiece and equivalent focal length of an Huygens eyepiece. The learning objective of these sessions are field lengths, eye lengths, positive and negative eyepieces and cardinal points. In this Ramdan eyepiece, it consists of two plano-convex lenses of equal focal length f separated by distance of 2/3 of focal length of either lenses, that is 2f by 3, where f is the focal length of each lenses of this Ramdan eyepiece. The convex surfaces of each lens face each other. The eyepiece is placed beyond the image formed by the objective of the instrument in which the eyepiece is used. This is the diagrammatic representation of Ramdan eyepiece, where the larger lens is field lens and smaller is eye lens. They are facing each other, means convex surface of each lens are towards each other and they are separated by distance 2f by 3, and the eye lens is having smaller size and field lens is having bigger size. Now we will check the condition for achromatism. The distance d between two lenses for achromatism is given by d equal to f1 plus f2 by 2, and f1 is equal to f2 is equal to f, as we know that both the field lens and eye lens are having same focal length. Therefore, d is equal to f1 plus f2 by 2, that is f plus f by 2 equal to f. This means the field lens should be placed in the focal plane of eye lens. In this position, any dust particle or scratch on the field lens would be magnified and the final image will be spoiled. To avoid this, distance between two lenses is kept little bit lesser than f, that is equal to 2f by 3. This does not cause much departure from the achromatism. Now we will see the condition for minimum spherical aberration. The spherical aberration is also reduced by making both the lenses plano-convex and their convex surface facing each other. The working of this Ramdan eyepiece is the final image formed by an eyepiece when adjusted for normal vision is at infinity. Hence, the image I2 formed by field lens lies in the first focal plane of the eye lens. As the focal length of the eye lens is f and the distance between two lenses is 2f by 3, the image I2 lies at a distance f by 3 to the left of field lens. For field lenses, the image I1 formed by the objective of the instrument acts as an object. From the lens formula, we have 1 by v minus 1 by u is equal to 1 by f. Here v equal to minus f by 3 and f is equal to f. So substituting these values in the lens formula, we will get u equal to minus f by 4. The negative sign indicates that the image I1 formed by the objective lies to the left of field lens. The rays coming from I1 after emerging from the field lens appear to come from I2. These rays emerge from the eye lens as a parallel beam. The focal length of this eyepiece, that is the focal length of Ramdan eyepiece or equivalent lens is given by f is equal to f1 f2 by f1 plus f2 minus t. Substituting all the values of f1, f2 and d in this equation, we come to the value f is equal to plus 3 by 4 f. As the final image formed by an eyepiece is at infinity, therefore the final image formed by an equivalent lens must be at infinity. For this, I1 should be in the focal plane of the equivalent lens. Therefore, the equivalent lens should be placed at a distance 3f by 4 to the right of I1, that is at a distance 3f by 4 minus f by 4 is equal to f by 2 to the right of field lens. Now position of the cardinal points. For this position of the cardinal points, as you know that h1, h2, f1, f2 and n1, n2 represents first and second focal points, principal points and nodal points respectively. The principal points equation, we have alpha 1 is equal to df by f2. Substituting the value of d, that is 2f by 3, value of equivalent focal length f as 3f by 4 and f2 as f, we will get alpha 1 is equal to plus f by 2. The first principal point h1 lies at a distance f2 to the right of I lens L1. Now the distance of second principal point h2 from I lens L2 is alpha 2 is equal to minus df by f1. Substituting the values of d, f and f1, we will get alpha 2 is equal to minus f by 2. The second principal point h2 lies at a distance f by 2 to the left of I lens L2. Now comes to focal points. For first focal point, the distance of the first focal point f1 from the field lens L1 is beta 1 is equal to minus f into bracket 1 minus d by f2. By substituting all values, beta 1 is equal to f by 4 with negative sign. So the negative sign indicates f1 lies at distance f by 4 to the left of the field lens L1. For second focal point f2 from the I lens L2, beta 2 is equal to f into bracket 1 minus d by f1, and we will get value beta 2 is equal to plus f by 4. That is, second point f2 lies at distance f by 4 to the right of field lens L2. Now the nodal points. As you know that the medium on either side of the eye lens or eyepiece is same, that is if the nodal points n1 and 2 coincide with the principal points h1 and h2 respectively. Now the position of the cross wires. In order to form the final image at infinity, the image formed by the objective of the instrument should be in focal plane f1 of the eyepiece. The cross wires should also be in focus with the final image. The cross wires placed in the first focal plane satisfy both the conditions. Therefore, cross wires are placed in the first focal plane of the eyepiece. The Ramdan eyepiece is called as positive eyepiece. We will see what is positive eyepiece. As the first focal plane is outside the lenses in object space and is real, hence this eyepiece is used to examine the real object or a real image. Therefore, it is called positive eyepiece. It is used in telescopes and other optical instruments where accurate quantitative measurement of distances and angles are made. So that's about the Ramdan eyepiece and its cardinal points and equivalent focal length. At the end of the session, we can be able to answer questions like MCQs, the Ramdan eyepiece, is sometimes refers to as dash dash eyepiece. It is a positive eyepiece. Which is correct specification of Ramdan eyepiece from the following? That is, it consists of two equal plano-convex lenses. It is true. The curved surfaces of lens face each other. True. Two lenses are separated by a distance equal to 2/3 of focal length of either lens is true. So answer is all the above. And next question, in the construction of Ramdan eyepiece, the eye lens forms the final image at 2f. In Ramdan eyepiece, the distance from the eye lens at which the image due to objective of the field lens f is formed by 11f by 12. By substituting the values in that equation, you will get the answer C. The component in an optical instrument used to increase the angular object field and to minimize aberration is called as field lens. So this is the end of session number 16. Thank you.